Good evening, everyone, and welcome to GEG UK on YouTube. I'm Darren White, I'm ringing the trainer. With me as well tonight, we've got SJ or Sammy and also Katie from GEG UK, and we're very, very happy to welcome as well Don Carney from Math Whiteboard. Hi, everyone. How are we doing? All right?
Good.
Oh, you sound it. That was really convincing.
Oh, I've just finished my dinner. I'm like in that sleepy food coma.
Oh, yeah, no, I know the feeling. Terrible, isn't it? How you doing, Sammy? All right?
Yeah, I'm good, thank you. It is still sunlight here in Yorkshire. I'm excited for what we're going to see this evening. I've already seen this, but I think it's just mega. So I'm super excited to hear what everyone thinks as well.
Absolutely. And all the way through this evening, please do, if you've got any questions or any comments, please do pop them in the chat and we'll do our best to answer them as we go through. But very good, warm welcome to you, Don, and thanks for joining us. Obviously, slightly different time zone to the rest of us. Just so everybody knows, do you want to introduce yourself so everybody knows who you are?
Darren, thank you very much for inviting me here today. I'm Don Carney. I'm from Math Whiteboard. You can see here on the screen, mathwhiteboard.com. I happen to be the CEO and one of the founders of the company that makes Math Whiteboard. So I'm really pleased to have the opportunity to show you today what Math Whiteboard is all about. And a pleasure to be here with you, Darren, Sammy, Katie, and the rest of the global education group, the Google Education Global Group for UK.
Brilliant, thanks. It's really great as well to see we're not just being GEG UK tonight, but we've got Alejandro in from Ecuador as well, which is fantastic. Lovely to be able to share beyond just the GEG UK as well. So what we're going to do is we're going to get started straight away, and we're not going to steal any thunder. But one of the good things about this evening, as we were saying before the show, we've got myself here, and I'm coming at things from a secondary perspective. Katie is a primary specialist. And of course, Sammy, you work in FE as well, and previously worked in alternative provision as well. So we really can kind of come at this from all sorts of angles, and we're really looking forward to seeing what Math Whiteboard can offer, not just maths teachers. And I think that's really important. So let's go ahead and get your screen on, shall we, Dom?
Okay, go for it.
There we go.
So just an introductory slide there. I've already introduced myself. If you need to reach out, you can always reach us on Twitter at our Math Whiteboard Twitter handle. And it's a web-based system, so you can always reach us at mathwhiteboard.com. So thank you again for inviting me to present today to the GEG UK group. And I'll obviously be talking about Math Whiteboard. You see it on your screen. And we believe this is the first collaborative whiteboard designed specifically for mathematics teaching and learning. So let me jump in and show you what Math Whiteboard is all about. Now, I have on my screen here two browser windows. There's a reason for that. I'll be showing you in just a moment how the Math Whiteboard can be a shared collaborative space where teachers and students can work synchronously on math problems. But before I do that, let me just create a whiteboard and show you what the whiteboard is all about. So I'm going to expand the page here, and we'll just take a look at one browser window for the moment. And before I get started, though, a couple of things. Math Whiteboard is a free and a barrier-free system. So the idea here is that we wanted to create a website where it's free. There's no price or cost associated with it, and it's also barrier-free. What I mean by barrier-free is that there are no accounts, there's no subscriptions, there's no logins, there's no passwords. It's just a website that you can go and use. Anyone can go and use it. And also, I happen to be using a Windows tablet while I'm presenting here, and I will be writing on the screen a lot with a stylus or my finger. But Math Whiteboard is a website. It runs in web browsers. I happen to be using Chrome, and that means it'll run on pretty much any device. So I'm running on Windows. It will also run on Chromebooks or iPads or MacBooks or Windows devices, wherever you want to run it. And although I'm using a stylus to write on the screen, everything I'm doing with a stylus, you can also do just as effectively with a keyboard and a mouse. And I'll show you that interface, the keyboard and mouse interface, soon as well. So let me jump in and show you what Math Whiteboard is all about. And I'm going to ask Darren to turn off my webcam because as soon as I start demoing, my face gets really close to the screen. And that looks kind of fun. No problem. So if you don't mind, Darren turning off the webcam there for me, and then I will jump in and show you what Math Whiteboard is all about. Okay, so let me jump in. I think Darren, you probably did you turn my face off?
I did, yeah.
Great. Okay, so think of Math Whiteboard as like a smart piece of math paper. For example, I can write some math, 1 + 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 + 2 is 3. I can change the math, and the answer updates dynamically. 2 + 2 is 4. I can change this 2 over here to an A, and then I can assign a value to A. And when I change the value assigned to A, the answer A + 2 updates dynamically. So A + 2, when A is equal to 2, is 4. I can change this 2 over here to a B, and then I can assign a value to B. So A + B, when A is equal to 2 and B is equal to 3, is 5. I can write more math on the page, maybe A - B, or A times B, or A over B, and we can get answers for all of these expressions as well. Now, underneath the hood is a very powerful computer algebra system that allows me to do not only the simple numeric arithmetic and the algebraic arithmetic that you've seen me do so far, we can also do some more advanced mathematics. So, for example, here is a definite integral. So we'll take a look at this math expression, and we'll get a solution for it as well. And of course, my A was misrecognized, so I wanted to rewrite that as an A. Now, when I go back and I change the value assigned to any of these parameters, A or B in this case, you'll see that everything on the page updates dynamically. So if I make A equal to 5, everything on the page updates dynamically. Or if I change the value assigned to B from a 3 to a 7, everything again on the page updates dynamically. I can even assign to A an expression like x + 1. Now x + 1 substitutes for A across the page. So as we know, learning math is about seeing connections between things. Here we're looking at the relationship between A and B with respect to some operators like plus, minus, divide, and so forth. In algebra-oriented topics, we look to see connections between other types of things like algebraic expressions and graphs and tables. Let me show you an example. So everyone's familiar with this math expression from your time in high school algebra, the slope-intercept form of a line equation, y = mx + b, sometimes it's plus c at the end, but it's the same math expression. M is the slope, b is the y-intercept. I've written it on the page, it was recognized. With a simple gesture, just the swoop of my pen, I can get a graph. I'll do that again. With a simple swoop, we can look at a graph. I can pinch and zoom the graph with my fingers. Now you'll notice if you are a math person that we have selected default values for m and b of 1. But I can change that. I can make m equal to a different value. So I can make m equal to like 2. And all of a sudden the graph will update dynamically. Or I can change the value assigned to m to a 3. And again, the graph will update dynamically. I can be more interactive by creating a slider for m, just like this. And now we can show very visually what m, or slope, really represents. What slope? That is slope. When slope is positive, it looks like this. When slope is negative, it looks like that. B is the y-intercept. And I'm going to create a slider for B here. The way you create a slider in Math Whiteboard is when you have an assignment on the page where you have a variable equal to a number. In this case, I have B equal to 1. A straight line down from the equal sign, just like that. Oops, creates a slider. And now we can show and change this value for B really interactively and really dynamically. Now, of course, we're looking at the graph and we're saying, what is B? I'm told it's the y-intercept, but what does that really mean? Well, let's plot this point, 0, B. And let's see if, when we plot that, we can now see what the y-intercept is. Of course, now we've given this very visual presentation of what the y-intercept is, and when I move the slider for B, we can really see what B represents. It's that point where the red line passes through the y-axis. So there's something I say often, and I think it's really important. Learning math is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression and a graph. Often in the math classroom, the math student, the math teacher, the mathematician uses a primary workspace, paper and pencil. That's where mathematicians do their work. It's the primary workspace. It's the natural space for doing math, using a pencil on a piece of paper. But we have all these complementary or secondary workspaces like graphing calculators or computers where we're looking at graphs or tables or solutions or animations or diagrams. all of a sudden we've got these multiple workspaces and they're all disconnected from each other. You know, how do you see the relationship or the connection between what you've written with a pencil on paper and what you displayed on the graphing calculator screen, entering with a keyboard? These workspaces are far from each other, not just physically, but also cognitively. So what we're trying to do with Math Whiteboard is bring together into one workspace, the primary workspace, the paper and pencil workspace, all of these mathematical representations, and allow the user to move fluidly between them. And then, of course, we hide behind the scenes all of the technical stuff. Let me show you another example that really demonstrates this in a very powerful way, this concept of having multiple representations in one workspace. So we're gonna look at a related rates problem. We'll look at a couple of cars. So I'll draw a couple of cars on the screen here. Yeah, those are cars. I'm sorry, I'm not an artist. We'll say this is car A, and we'll say this is car B, and we will give length to the road. We'll say the road has 1,000 units of length. And then over here, I'll write a couple of math expressions that describe constant acceleration and constant velocity. So the first car A, we'll say has a constant velocity of 80 units of distance per unit time. That's a linear function. We're basically saying car A is going 80 miles an hour. Car B is a police car that has to accelerate to catch car A. We use a quadratic to describe constant acceleration. So in Math Whiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. Under the More menu, I can turn on math sketching, and I get this slider that pops up. And the slider, on the right-hand side of the slider, there are these player controls. And when I press the play button, we can see the cars moving across the screen in an animated simulation as described by the math I just wrote on the page. Pretty cool. Pretty cool for us as adults. Imagine what happens when you show this to kids in the classroom. You know, their heads explode. Make the car go faster. Make it bump up and down. All of a sudden, they're asking great math questions that require knowing more math in order to answer the question. Of course, you know, from a very higher level pedagogical perspective, really what we're doing here is we're connecting this abstract algebraic notation on the left-hand side with a very concrete example that we're all familiar with, cars driving along a road. And, you know, it's really important when you're learning math from a conceptual understanding perspective to understand the why part of the math. Like, why do we need to learn this algebraic notation? Why do we need to learn algebra? Who cares? Oftentimes the kids will ask. Well, it's because the algebra can be used to model all sorts of things. And, you know, pretty much anything in our life can be modeled with algebra. And in this case, we're looking at something that kids and everyone's very familiar with. That's cars driving along a road. But, you know, that's a very high-level pedagogical perspective. From a very practical perspective, this is a related rates problem. And related rates problems show up on standardized exams all the time, especially in algebra. And with related rates problems, we're typically asking a couple of questions. The questions are, you know, at what point in time does something happen? Or at what point in distance does something happen? Here, the question is, when does car B overtake car A? We can see from the simulation it happens right about there. Well, that is an observation, not a math answer. We want to get to the math answer. How do we do that? There's a couple of different ways to do that. We could set these equations equal to each other and solve. And of course, as I showed you, we have a very powerful computer algebra system. I could just do that on the page here and we can get to the answers. The way I like to solve this, though, is by plotting these two functions and then looking at the graphs and seeing if there's something we notice that's interesting. And of course, when we're looking at systems of equations here, we're typically trying to find the intersection points. And we can see in the graphs here that there are two intersection points. One there at the origin, that's the point at which the cars start. But what we're really interested in is this point of intersection out here in the quadrant where the quadratic or the curved blue line here overtakes the straight line, the red line here. That's when the quadratic overtakes the linear, and our hypothesis is that's when the accelerating car will overtake the speeding car. So we can see right here in the graph that point happens to be at about 8 units of time and at about 650 units of distance, right? So that's our hypothesis. When time equals 8, the car should be at the same spot. So I'm just going to take the slider over here, and I'm going to move the timer over to 8. And that's what we're simulating here is 8 seconds into the simulation. we can look at the simulation. We can see, well, the cars look like they're at about the same spot, but we're just eyeballing the graph and we're eyeballing the simulation. It could be 7.9 seconds or 8.01 seconds. Let's prove this. The way we prove things in algebra is through substitution. So I will substitute in the value of our hypothesis when time equals 8 to see if the location of car A along the x-axis is what we think it is from the graph, about 650. Let's see. 640, pretty close. If B sub x is also 640, then we have proven the hypothesis. Okay, pretty cool. So I love this example because it demonstrates in a very powerful way how having multiple representations, or all representations in the same workspace, and having everything connected can be very pedagogically powerful. So when this, and by the way, everything is connected. We've got algebraic expressions, we've got a simulation, we've got solutions, we've got a graph, we can look at a table of values, and everything's connected. So when the student says, make the car go faster, well, we can just change the 80 miles an hour to 90 miles an hour. And now all of a sudden, look, the graph changed, the point of intersection moved. The solutions changed as well. So I'm going to pause for just a moment to see if there are any questions. There's still a bunch more I'd like to show, but if there are any questions or comments that folks have, happy to field the questions.
Yeah, we did have one question in there. Loads of fantastic feedback, Don, obviously. Amazing representations. But this one from Sangeeta, how about some matrix computation and product 2 matrices? Can that sort of thing be done?
That's great, and that's a great question, and yes, they can be done. So we recognize not only the matrix notation, but as I'll show you in just a moment, we have a keyboard interface that allows for the entry of matrix notation. I'll just show you a very quick example here. So I think here's just a very simple. Let's do a very simple matrix operation here. We'll do this over here and over there, and we will multiply this by 2. And we will solve that. Of course, we can do more complex things like determinants and so forth. But the answer to the question is yes, we could do matrix operations.
Fantastic. Yeah, loads of great feedback coming through. And as expected, people blown away by just how easy this is to work with. And just to clarify as well, for those people that are watching, you're doing quite a lot of erasing of things and changing things. But what I love about this tool is you're not having to go away and pick up a rubber. You're just scribbling over the top of it and it knows to get rid of it, just as if you were writing on a whiteboard and you rubbed it out with your finger. There's no pick up this tool, put down that tool, oh, I'm clicked on the wrong one. It's all very, very simple.
Yes, so I should mention that this Math Whiteboard has its origins in some PhD thesis work that was done at a university here in the United States, Brown University. That's where I did my PhD in computer science there, and my team, we all did our work in computer science there. And this was done in a research lab that focused on user interface technology and on educational technology. And part of the challenge in building a system like this is trying to keep it simple. So even though it looks pretty simple, a lot of thought and research goes into trying to do as much as we can to keep the user experience fluid and simple. And you'll notice that so far, the vocabulary of gestures is really small. I've used so far 3 different gestures. So there's, if I have y equals mx plus b here, I've used a scribble erase gesture, which looks like that. So that's one gesture. A second gesture is a graphing gesture, like that. A third gesture is the gesture to create the slider, just like that. And that's basically all the vocabulary gestures that you need to know to really be a power user within Math Whiteboard. There are just 3 of them. There are 2 additional gestures that are less frequently used. You may see me using them. There's one gesture to create a blank coordinate plane is just a big plus. And that will give you a blank coordinate plane upon which you can just graph your, whoops, oh, I did the graphing gesture a little too slowly. Just a quick gesture into the graphing area. And of course, we get the graph in there. If a big plus is a 2D coordinate plane, then what do you think the gesture is for a number line or a 1D coordinate plane? It's just a straight line across the page here, upon which then I can graph things like numbers. Or I can graph other math expressions that you might plot on a number line like x minus h greater than 0. Then we can plot this, and if we create a slider for h here, then we can manipulate the value of h, and we can see how that is impacted on the presentation in the graph. So pretty cool. We tried to keep the user interface as simple as possible.
Brilliant. And like you say, very, very few gestures to have to remember, which is brilliant.
Yes.
But I know you've got a lot more to show us, Don. So
yeah, let me continue on. Continuing with this idea of being able to see connections between things, we have a very unique bit of functionality in Math Whiteboard. I don't think you'll see it anywhere else. Within Math Whiteboard, we have this ability to test for equivalences on a page. And what do I mean by that? So under the More menu, I can turn on Highlight Equivalence. And by the way, this is a bit of functionality that is also applicable at the lower grade level. So far, you've seen me do a lot of things at the secondary level, where I still want algebra oriented. This functionality can also be applied at the lower grade levels, and I'll show you how. So, and this idea of algebraic equivalence testing works as follows. So, for example, the number 3 and the number 2 are not equivalent to each other, so they're color coded differently. And the number 4 is not equivalent to 3 or 2, so again, it's color coded differently. But the number 6/3 is equivalent to 2, so it's color coded the same as 2. And the number 4/2 is equivalent to 2, so again, it's color coded the same. This is great for lower grade levels where we're looking at equivalent fractions and decimals and so forth. But it's also applicable at the algebra level where we might be looking at equivalent algebraic expressions. So for example, let's do a plus b and b plus a. Okay, so those are equivalent expressions, but a minus b minus a are not equivalent, and a times b and b times a are equivalent, but a over b and a over b, let's get a better b down here, a over b and b over a are not equivalent to each other, so they're color coded differently. And of course, this is what you've seen me do so far is the numeric equivalences and simple algebraic identity equivalences. This can also be applied at the higher grade levels for calculus, for example. We might look at trigonometric identities. So for example, tangent of theta is not equivalent to sine of theta, so they're color coded differently. But sine of theta over cosine of theta is equivalent to tangent of theta. So now these are color coded the same. Pretty cool for identities and equivalences so far that we've seen, but possibly the most powerful way in which to use this color coding is in step-by-step problems. So for example, let's take a look at this problem here. What if we had 2x plus 3y equals 4? If we wanted to solve for x here, what would we do? The first thing we might do is move the 3y over to the other side. So let's do that. So the first step here might be 2x equals 4, and then we're moving plus 3y over, right? So that should be 4 plus 3y, right? Wait a second. It's not color-coded the same. We know that every step in a step-by-step problem should be algebraically equivalent to any other step. So, but this is color-coded differently, so it must mean it's not equivalent, so I must have made a mistake. Oh, you know what? I forgot. When you move things across the equal sign, you're supposed to change the sign, so it's not plus 3y on the other side. It should be minus 3y over here. Okay, cool. It's the same color, so it must be an algebraically equivalent step, so I must have done the right calculation. So what we've done there is we've given immediate feedback through color coding that the student made a mistake. And now the student knows with confidence that their first step is correct and they can continue on. So now, of course, the solution is 4 minus 3y over 2. And now it's color-coded the same. So we know we got to the same solution here. And of course, it can be very disheartening for students or learners to go through a 5 or 6 or 7 or 8, 9 step process, get to the bottom and realize, oh man, I made a mistake. Where did I make the mistake? Maybe if I made this mistake really early on, I have to do it all over again. Or if I can't figure out where I made the mistake, I have to start from scratch. that can be very discouraging and disheartening. So what we're doing here is we're giving immediate feedback, which I think is a cool bit of functionality. I think something that you may not see anywhere else. So I'd like to continue on with showing you a few more bits of functionality here. I'm going to show you what, this is possibly one of the most important bits of functionality here, is that the Math Whiteboard can be shared. So every Math Whiteboard has a unique URL. You can see it up there in the browser window. When I click on copy link, that will copy the browser URL into my memory, into my clipboard, and then I can paste that into a Google Classroom or an email to a student or a course web page. In this case, I'm just going to paste it in this browser window over here because I want to show you what the interaction between a teacher and a student might look like. So the browser on the right-hand side represents the teacher working on her computer, and the browser on the left represents a student working on their computer, maybe not even in the same room. So when the teacher on the right writes something, so for example, the teacher might write something like y equals x, and then tell the student to change that to slope-intercept form. So the student, so I wrote that originally on the right. I'm going to edit it on the left. So I'm editing that. So I'm making that y equals mx plus b here. And of course, all of the tools, this is a shared synchronous page. So that's what Math Whiteboard is. So all the tools that we have available, like creating graphs or creating sliders, they're all available here because this is a shared math page. Now, this is pretty cool so far. One of the things that we've seen math teachers do, and this was a bit of functionality we did not intend to be used this way, but math teachers are very creative. So with any Math Whiteboard, you can open up the tab on the left-hand side and you can look at the pages because a Math Whiteboard can have multiple pages. And I could add a page by just clicking on the plus button, and that will add a blank page. But if I click on any page here, I can hit Control-C and then Control-V, and I've got several copies of the page. Now, the creative thing that we've seen math teachers doing is that they will assign to each of these pages a different group. So maybe on page 2, they assign this to group 2. And on page 3, they assign this to group 3. Oops, I want to be group 3 over here. Well, let's do that 3 again. And we'll get rid of this. And then maybe on group 4, on slide 4, we have group 4. So this is group 4 on slide 4. So you can see each of these slides over here. You can see the teacher can see in real time what's happening on those slides. So let's say, for example, this student on the left-hand side is in group 3. And maybe this is 2 students working together because the teacher has assigned to each of these slides a group of students. Maybe this is Mary and Johnny working together over here. So maybe one of the students over here writes a math expression because they're working through the problem. The teacher on the right-hand side can see what's happening on that page in real time as it happens on the page. You can see that on the right. You can see that slide number 3 has been updated with the green ink there. And maybe the students over here are working on some other really interesting issues like smiley faces, and the teacher can watch them in real time as well. So kind of a unique use of the system here that we didn't expect, but we love to see the creativity from teachers. I'm going to continue on. I want to show you a couple more bits of functionality here. But the key thing there is that these math boards can be shared like a real-time workspace that's designed specifically for mathematics. There are a lot of whiteboards out there that can be used collaboratively for real-time communication. But our Math Whiteboard is designed very specifically for mathematics. And math teachers are well known to have a lot of worksheets. So I have a folder here with some worksheets in it. These are just math worksheets. If I were to open one of these, solving systems of equations, I can just open this worksheet in Acrobat Reader here. We can look. It's a PDF file. It looks like any other math worksheet. But I can take any PDF file and drag and drop it right into the Math Whiteboard space. All of a sudden, that PDF file becomes the background for my Math Whiteboard page, upon which I can do all of my cool Math Whiteboard stuff like write math. I can put graphs on the page. I can put solutions on the page and get answers and so forth. Whoops, I want to change that to a 2 here. And of course, I could just use the annotation tool. I could put on the draw pen, and maybe I want to work on this problem here. So we solve this problem here, and then maybe down here we put an answer. or maybe I want to work on this problem here and work through. So all of a sudden, what was a static PDF file that we printed out on paper and handed out to our kids becomes a live, interactive, dynamic workspace that can be shared synchronously with our students. So we've given life to the PDF worksheet. Now, of course, in its simplest form, you could just use Math Whiteboard as a PDF annotation tool. You know, we didn't really need all this need to use all this math stuff over here. I could have just put any math worksheet in here and annotated, or it could have been a chemistry worksheet or a history worksheet. It's just in a simple form. This is just an annotation tool for PDF files, which is pretty cool also. A couple more bits of functionality I wanted to share with you as well. So I mentioned early on that the Math Whiteboard can be used on any type of device. And we know that there are lots of devices out there that don't have a touch screen. So everything I've done so far within Math Whiteboard, you can also do with a keyboard and a mouse. So far I've been using these modes. There's a draw mode up here. That's for drawing. And there's a math mode up here. That's for writing math. So the draw mode is used for drawing stuff, maybe a smiley face. And the math mode is used for writing math. Now, you wouldn't use the math mode to draw a smiley face, right? Because that doesn't really make much math sense, right? The recognizer tried, Math Whiteboard will try to recognize it. In this case, it recognizes it as a 0, but that doesn't really make a lot of math sense. We also have this math typing mode up here. When I turn on the math typing mode, I can type math on the page with my keyboard. I'm going to use my physical keyboard right now just to type some math on the page. So I'm going to type y equals ax squared plus bx plus c, right? That's me typing with my physical keyboard. Not everyone knows how to use a physical keyboard to enter math notation. So for example, some folks may not know how to type x squared with a physical keyboard. Folks who are familiar with it know that you can type x and then shift 6, which is the caret, or circumflex key, and then put a 2 in, and that'll be the x squared. So for folks that are more comfortable with the pick and pick kind of keyboard, you can use the pick and pick kind of virtual keyboard down here to enter math notation. So for example, if I just pick some keyboard here, y equals x with a square key here, now I've got that math expression. Now, just a hint for any folks who might be typing math, the swoop gesture doesn't really work with typed math. What you'll want to do is you'll want to go to the insert menu, insert a graph. That'll put a blank graph in the graph area. And then you can drag and drop your math expressions right into the graph area. And the A, B, and C are clickable here. I can click on A, B, and C, and I can get sliders for A, B, and C. And that allows me to manipulate these sliders and kind of dynamically explore the math expressions. Of course, sometimes you may be wanting to just have typed math on the page anyway, because when you're sharing these things with your students, you may not want your big, ugly handwriting on the page. Something like this. It not only doesn't maybe not look so good, but it takes up a lot of space. So underneath your handwriting, right there, is a button. The button will shrink we'll get rid of the handwritten math, and I'll be left with just the typeset math. So I'm going to do that. I'm going to click on this button, and my handwriting goes away. And now I'm left with just the typeset math. And I can get rid of this arrow here. And then I can drag and drop this math expression right into the graph area if I want to. I could also put another graph on the page here if I wanted to, and drag that over here. And you'll notice there's a y equals mx plus b, there's a b in there, and then the y equals ax squared plus bx plus c, there's b. So there was one b slider on the page. And the slider for b associates with any b on the page. So anything associated with b will be affected accordingly. But let's get rid of these two things here for the moment, because if we're presenting these things to students, we may want to put some text on the page, like instructions. Up here, there's a text box button. When I click on the text box button, now I can enter text on the page. So, for example, I might say, play with these sliders to understand the transformations. Something like that, right? That's some instructions, but these text boxes are really rich. You can do some cool things. So one of the things you can do is you can embed a YouTube video. So if I click on edit here, and then I click on insert, and I select media, I can then go, I have queued up here in the browser tab, I have a, I think this is a video. This is like I think this is a Telecom video here. But as you know, with all YouTube videos, there's a share button. I can click on share, and then I can get the different means by which to share it. One of them is an embed code, so I can click on embed, and then I can copy the embed code, and then I can go back to my Math Whiteboard, and I can paste that embed code right into my Math Whiteboard, and now all of a sudden I have a YouTube video built right into my Math Whiteboard, and it's built in, it's embedded. So when I click play, you stay in the same workspace. You know, it's not opening up in a different browser or in a different browser tab. We're staying all within the same workspace. And that's sort of the model here that we're using for Math Whiteboard. We want you to stay all within the same workspace because it's, oops, you can hear Saul talking there. So we want you to stay within the same workspace. And we think that's helpful for learning because you're not switching contexts all the time while working on one problem. So Math Whiteboard does a bit more, but I think I've covered a lot of ground here, and I think I've given you a good flavor or a good taste for what is possible with Math Whiteboard. So let me pause and see if there are any questions or comments or thoughts that folks have.
Thanks, Don. That was brilliant. There's been a few questions in the chat, but Sammy's been really good at answering some of those as we've gone through. One of the questions I know I asked you beforehand, I think people might find useful, is when it comes to saving the progress of the work that's done, although you can't save the whiteboard and come back to it later because there's no login or anything like that, which is obviously brilliant from a GDPR data protection perspective, but you are able to save the work that you've done as a PDF. Is that right?
That's correct, yes. So I could go to the print menu of the browser and select print, or well, yeah, the drop-down menu of the browser, select print, and then what that'll do is it'll save each of the pages as PDF files. So you know, if you select the destination to be saved as PDF, then the system will render the PDF file right there. It's taking just a moment to render, but yeah, very easy to just print the PDF.
Brilliant. And as Sammy says in the chat there, you know, the ability to embed those videos so you're not having to navigate away, so helpful for students who, you know, are easily distracted, could easily end up heading off down a rabbit hole on YouTube, having a look at cats or, you know, all sorts of random things that apparently is on there. The fact that we can prevent that from even needing to happen in the first place, you know, is absolutely superb. Anything particular from yourself, Katie or Sammy?
I mean, yeah, I was blown away with that. That was great. And I know for like younger children, seeing the colours of the equation sort of staying the same colour, well, and then they can see if they go wrong, and then it will make them think, hang on, what have I done here? It's now a different equation and stuff. That would be so handy.
Yeah, absolutely. I mean, I used to have I can remember a few years back, I had a bottom set year 9 class. And if they were trying to do one of those kind of like sequential solutions, they wouldn't have had a clue potentially that they'd gone wrong at step 2 and might have gone all the way through to step 9, then found out they're wrong. And for them, going back all the way through and trying to work out where and do everything again, particularly if you say to them, but look, you've done all of that right, it was just you were wrong in step 2. Actually, sometimes that's a real killer for them because they're like, oh my God. Whereas this just highlights that you've got that immediate feedback.
Yeah, early on.
Yeah. And, you know, equally, if they're working on their own independently, fantastic, I think. About you, Sammy?
Well, I have been trying to get my students, and their work is actually here, to do their teacher assessed grade work. But some of them couldn't come in because of their bubbles and their family situations. So I actually imported a PDF into Math Whiteboard. They then wrote on it. I could see it live and invigilate it live remotely. And then we've exported it as a PDF, and we've now got the recorded evidence for their teacher assessed grade. So it's solved a massive problem for us.
Phenomenal. How good is that? Such a great
really good. And the response was so great, and they really loved it. And you know, no one's been left behind in this teacher assessed grade crazy world about what's gone on. So yeah, thank you, Don. It's been a life changer this week.
That is fantastic to hear. So glad to hear that. You know, just another anecdote. I was speaking to some teachers earlier today whose students, and of course, you know, a year ago, teachers around the world were faced with this transition from a synchronous environment in your classroom where you're working real time with your students to an online environment where a lot of the communication is asynchronous, and then any of the synchronous communication that happens is really challenging in the math classroom because you know, math is a subject area where you need to see it and hear it at the same time. I need to, you know, explain it and show you at the same. I cannot just explain the math to you, and I cannot just show you the math. They're both components have to be there. And I was talking to some teachers earlier today whose students will take pictures of their assignments and then text the assignments to the teacher. You know, maybe they say, you know, teacher, I have a problem with my homework assignment. Can you help me? So the teacher says, take a picture with your phone and then text it to me. And then the teacher gets it on their phone and then has to figure out how to mark it up and then send it back to the student. So in addition to being able to import PDF files, you can also drag and drop or import images. So you could take an image from a phone, drag it in here, put it on the page, have the student do that, and then the student can share the link with you. You can mark it up, and then the student can see in real time as you're marking up their assignment, which is pretty cool.
Brilliant. And of course, you could screen record as well while you're doing that.
Sure, absolutely.
And you know, keep that screen recording for future use, because chances are if one student's had an issue with it, there might be others as well. Absolutely superb. I think it's a fantastic tool. So many possibilities, far beyond my capabilities in the maths perspective, which is why it's so good to have other people on the call who are much more able than I am, because I was just blown away by the cars, not the drawings, but the animation, obviously.
Sorry, my drawings aren't that good.
So I don't think there's any more questions in the chat. I've been having a look, and I don't think there's any more questions. So if anybody has got any further questions, just kind of like last opportunity to pop any of those in the chat. And while we're doing that, I just want to say a huge thanks to you, Don, because I think this is just without stealing Sammy's words, it is an absolute game changer. And the fact that it's free and there's no login, particularly over here in the UK with GDPR as it is, which can cause frustrating blockages for the use of tools. The fact that there's no login, there's no data being collected is so helpful, because you can just get on and use it, and you haven't got to wait for clearance or worry about where that information is being stored. So I think it's absolutely superb, and thank you so much for taking the time this evening to come and show us, because I think it's going to go down particularly well. And I know we'll share the recording of this afterwards with all of the GEG community, and there's about 400 of us on there now. Awesome. And I think it's going to be a lot of happy faces, and as we said at the outset, not just maths teachers, because this is so useful in so many other fields as well.
Awesome. Thank you so much. Oh, go ahead, Darren.
No, I was going to say, any final words from you, Katie or Sammy?
It's just, I'm still like, some of that maths I'm still reeling from and being like, yeah, I remember doing that. It would have made my life so much easier being able to see like links between equations and graphs at the same time and like playing with them. That would have been great. It's bad.
And also, how much time do you save doing a graph that way than giving everyone a piece of squared paper and saying, right, draw a graph? Yeah. You know, how much time is wasted redrawing a graph, drawing another one, when actually all you got to do is swoop.
Yeah.
I love the swoop. It's my favourite thing this year, I think.
The swoop is epic, but when I've made some videos on Math Whiteboard at the weekend, and my favourite thing was actually the scribble. And I found myself constantly going, here we go with my favourite thing, just scribbling. And just, so if anyone else wants to join me in the scribble love, I'd be more than happy to form some sort of collective on the scribble love.
Absolutely. Hashtag scribble love could get some interesting replies on Twitter, I think. But Thanks. Listen, Don, thank you so much for giving up your time this evening. And thanks to you, Sammy and Katie, for joining me as well. It's really appreciated. Thanks to everyone who's joined us this evening. Hopefully you'll take this away and share it with other people within your schools, colleges as well. And hopefully we can make life a lot easier for people that I think are going to be really, really pleased to get their hands on this fantastic tool. Okay, so we'll see you again soon. Finally, again, thanks, Don, for giving up your time this evening. And thanks, everyone, for joining us. Take care.
Thanks for having me.